Okay, folks, we are a little bit late, so we'll start right away. We have Joris here, and he's going to tell us about Apache Arrow.
Yeah.
Give him a warm welcome.
Yeah, thank you. So, quickly about me, I'm involved with Pandas, GeoPandas, a bit of scikit-learn, and currently I'm working part-time at Ursa Labs. We'll come back on that later on the Apache Arrow project. So, Apache Arrow, the title of my talk was about a cross-language development platform for in-memory data, which is a bit vague. Doesn't really directly say to you probably what it does. So I hope to make it a bit clearer in my talk here. It's a relatively young project, started a few years ago. One of the main drivers was and still is Wes McKinney, so the original author of Pandas as well, together with some other people from other open source ecosystems. So it's a project on the intersection with data science, big data, tabular data, and one of the key focuses of the project is on open standards for computing. And as introduction to the ideas behind the project, I first want to go a bit more in detail on that aspect. So if you think about open standards in like our computing community, and so you have some open standards you will all know, like for example JSON is, at least the structure of JSON is an open standard. What you put in a JSON file can then be still whatever, but also other file formats that are used in the ecosystem, in the community, like NetCDF or AGF5 are standardized formats. An example that is not a standard format is, for example, CSV. You can put a lot of data in a lot of different ways in a CSV file, and that's also one of the reasons that the Pandas Read CSV function has so many options to be able to read those. But the Apache Arrow project is focusing on standards for in-memory data, and for that we also have a very good example to give you an idea what it is in our ecosystem, which is NumPy and its memory layout of the array, the strided multidimensional array. It's not something specific to NumPy, and you also have this concept in other languages, but it's a standard, and it makes that you can share data without much overhead between processes or between libraries. You can reuse algorithms that are written not necessarily specifically for NumPy, but can work with this standard data buffer, so you can reuse algorithms, I/O functionality, etc. So this is for array data. The Apache Arrow project focuses on columnar tabular data, so typically data frames, and in this area you have no standard whatsoever. You can find data frames or columnar data in a bunch of different languages, systems. For example, so in Python you have the Pandas data frame as the most known example. We also have other data frames nowadays in Python. R has a couple of data frames. Julia has data frames, but also in big data systems like Spark has its data frame. Each SQL database system has its data frame like layout. So but they all have their own proprietary memory layout. And saying proprietary not because it's necessarily closed source, but it's because it's so internal to their library that you can't really interface directly with the memory, which also means that you can't reuse code across those projects, that you have high serialization costs if you want to move data around. And to put this in like a different way, so you can see those traditional libraries or database systems as having those different components very tightly coupled. So to give the example of Pandas, Pandas has quite some code for I/O. For example, the CSV reader is most used feature probably of Pandas. Custom code to read a certain file format into a specific memory layout. In Pandas called the block manager. It's very specific to Pandas. And then we have in Pandas a lot of our own custom code to compute things on this memory, and then we provide a user API to the user. So Pandas has all those things, and for example, in the computational code, we have quite some Cython code to optimize group by operations, and currently it's very hard to reuse anything of that outside of Pandas. And then R has all those different components. Julia has all those different components. Each SQL database has all those different components. So tightly coupled components makes that you can't share data, you can't share algorithms, etc. So you have a situation like this where you have different database or data frame systems, different file formats, and they all need to do a lot of conversion, copying to move data from one file format to one system or between different systems. And the idea of Arrow is to also come up with a standard in this area and to have, this is a bit an hypothetical future where you have the standard that all different systems can talk with or are implemented based on to have a more efficient ecosystem here. So to come back on the previous figure, instead of having all those components tightly coupled, try to have them separate. Most of them are still provided in the Arrow project, but each of those components has its public API. You can use what is needed. It's based on a standard. Things can be shared. The only thing that Arrow doesn't really care about is the front-end API. So the idea is for Arrow to provide those building blocks that other projects can use to provide its API. So long introduction to then come to what are now the core aspects of the Apache Arrow project. So that is this open standard. It provides or it specifies a standardized language independent, so cross-language memory layout for columnar data. And in addition to that, accompanied by a specifications for messaging protocols to share the specific memory layouts between systems, between processors. To give a small note on the memory layout, I won't go into details here on the exact inner details of the format, but some aspects of it to put it into light of some shortcomings of Pandas. So it provides a lot more native data types, for example, strings, integers with, come back to that, strings, dates, decimals, but also nested data. So if you have list-like data or JSON-like data, and you want to put that in a column that's natively supported, everything is nullable, so every data type can support missing values. Memory can be chunked, so if you, for example, have two tables that you want to concatenate, it doesn't necessarily need to make a copy. And then, this layout is a columnar layout optimized for efficient processing for modern computing techniques. And then a second part of the project is there are a lot of libraries that implement this specification of the memory format and the messaging protocol. So currently there are already quite a bunch of languages available. C++ and Java are like the two core ones, but also we have C#, Go, JavaScript, Rust, and the C, MATLAB, Python, R, and Ruby ones are based on the C++ implementation. In addition to an implementation of the standard, those libraries can also have computational tools based on the standard, but that is a bit varying depending on the implementation. For our concern, let's quickly look at, so the Python interface is the package PyArrow. It gives you this implementation of the standard, and in addition it also has a lot of functionality to do conversion from Python to Arrow memory. So for pandas, but also for NumPy, for built-in Python objects. And here's a small code snippet where I convert pandas data frame to an Arrow table, and you can convert it back. And those implementations, those conversions are implemented very efficiently. That's what's in the Apache Arrow project. So for what is it used? So I'm going to give a few examples in those three areas. So accessing data, input, outputs, getting data from a certain file format, but also then moving data around between processes, between libraries, and actual analytics on top of Arrow. So some examples for this. First thing was the access, so reading and writing file formats, interacting with databases. And I think the best example in this area is the Apache Parquet file format. So it's another Apache project. It provides a file format specifically for columnar tabular data, a binary format, an open standard as well. Until recently, for a few years, it was not used very much in the Python ecosystem, but it was used a lot in the Hadoop ecosystem already in the big data Hadoop world. But nowadays, it starts to increasingly be used in Python as well. And so in Pandas, you can read and write Parquet files with, the, for example, the read Parquet function. And this is based on functionality from PyArrow. In Pandas, you also have another option to use fast Parquet, but PyArrow provides this functionality. And to convince you to use Apache Parquet, if you compare it, for example, to CSV, so you will write and read Parquet files much faster than a CSV file. It will also be smaller on disk because Parquet has a very good built-in compression. It will also preserve your data types, which is not the case with CSV because it's a binary format, it stores metadata. And when reading, you can also read only parts of it, what you need if you have certain columns or partition data sets. It supports those things as well. So that's how you can use, or how PyArrow is used in Pandas for Parquet. But what I mentioned before was that the goal of Apache Arrow is also to share implementations. So the first one is what you saw on the previous slides, to read it in Python, but also in R. If you load the R library, you can use a read Parquet function. And also in MATLAB, there is a Parquet read function nowadays. And they are all using, sharing the same implementation under the hood, which is the C++ implementation to read Parquet files into Arrow memory. And all those languages can then convert Arrow memory to their own custom formats. A second example here to interact with databases is the TurboDBC project. It's something developed externally from Arrow, but it's using Arrow to give you a high performance interface to a database. So it's a project that gives you the standard database API of Python, but in addition to that, it also gives you access to, instead of the row-by-row interface, the standard interface of Python, you can also ask for, give me batches of Arrow data directly from the database. A small note here is that it depends very much if this gives you a speed up on the quality of the ODBC driver. And for example, if you're using Postgres, they have a built-in ODBC driver, but it's not a very good one. So there you won't see much speed up with this. But for databases that have a good ODBC driver, then it can give you a significant speed up compared to the sometimes slow read SQL function of pandas. Some other examples in this area. So I already mentioned Parquet as a file format that is supported by Arrow. Arrow also, or at least the C++ implementation, also has a CSV reader, a line delimited JSON reader, and there are some more planned. Cartotech is a library, a Python library to manage collections of data sets that was recently announced that it's using Arrow under the hood. TensorFlow recently also announced a dataset interface based on Arrow. The VEX project that was presented this morning also has, you can use there as one of the options, Arrow to open a data frame and some more. So that brings me to second example, second type of use cases, which is to move data around. So it has this is based on the IPC protocol in standard in Arrow, which can give you zero copy inter-process communication, and so which will allow you to pass data around, for example, from Java to C++, without needing to make a copy. Here, a typical example is they use this functionality to speed up user-defined functions in PySpark. So PySpark, the Python interface to Spark, has a functionality, a user-defined functionality where you can, in Python, write a function, and until recently, or I think it's still the default, what happens is that the data from Spark is serialized, sent to Python, and then the function that you define is called row by row, which gives you a not very performant solution. So in the new, something they released in one of the recent releases is what they call a pandas UDF, where they use Arrow under the hood to increase the performance. So what happens is that they, in Spark, they convert their data on which you want to apply a function to Arrow. This is sent without needing to make a copy. Python can access that same Arrow memory, convert it to pandas, apply the function, this time on a full series for the batch that you're doing, and you send the results back. So, of course, depending on the data type, there can still, in the conversion, for example, from Arrow to pandas, it might be that you need to make a copy there, but also, if that's needed, it's implemented quite efficiently. And here are some numbers from a blog post when it was introduced, comparing the previous implementation with the new implementation based on Arrow to send data from Spark to Python. And you see, so the shorter bars is the faster results. Another part, this is part of Apache Arrow itself, is the Arrow Flight framework. So it's when, not for sharing memory directly, but for sending data, for example, over the network to a different machine on the same network. So it's based on gRPC library, and this can give you high performance communication of Arrow data. Some other examples in this area, I won't go, I don't have the time to go in detail on those. Plasma is an object store that is also included in Arrow. BigQuery is using, so the Google big data storage solution is using Arrow internally as well. Gandiva is a LLVM-based expression compiler, so you can define an expression to compute something on Arrow data, and then it's compiled on the hood on the fly using LLVM technology to evaluate that expression on Arrow data. This is implemented in C, in the C++ library, and for example, Dremio, a commercial company working a lot on the Arrow ecosystem, is using that in a Java-based database system that they provide, so they again can send their data without making a copy to the C runtime, use their Gandiva to run an expression and send back the results. Lastly, we can also use Arrow as the basis for actual analytical infrastructure, either using just the memory representation of Arrow, but Arrow also provides some computational tools, either precompiled or what I just mentioned, the Gandiva LLVM-based one. Dremio is an example that I just mentioned, and the other another example is Rapids, which was already presented this morning. So I won't go into detail here, but their data frame library, QDF, uses the Arrow memory format as the internal representation, but then not just but using this the same representation, but on the GPU. You could also think about, can we use Arrow as the underlying technology for pandas? Because in the end, as I mentioned before, when explaining a bit the memory formats, it tackles quite some of the current issues that you can have with pandas. And here I'm showing it's some actual code. It doesn't do much more than just representing itself. So I have a data frame, and you can see here, for example, I have integers with a missing value. Arrow supports that natively. I have a string data type. I have a decimal data type. Timestamps can have other resolutions than just nanoseconds as in pandas. There is support for nested data. It's also something that is often requested in pandas, but we currently don't really support that. So that are data types that are supported by Arrow. So to extend this in pandas, this could be a way to do that in the future. This is very hypothetical, and we are not yet sure where pandas is going, or maybe it will be different projects, like there are already different data frame projects popping up. But there is one project experimenting with that is actually already usable. You can try that out. So Uwe Korn, one of the core developers of Arrow, wrote the Fletcher package, which is using the pandas extension array interface to store your columns in your data frame are actually backed by Arrow arrays. And also part of the functionality is then backed by Arrow or some custom extensions. I don't need this now. Let me. Where is my? Sorry. So that's something you can look at if you want to experiment with using Arrow inside pandas data frames. So that brings me almost to the end of this talk. I hope that I gave you a little bit a better idea of what Arrow provides. It's used a lot like behind the scenes. So as an end user, you don't always directly interact with it, but in the end, it's already used in a variety of applications. It's supported by many languages. There is quite some, a lot of industry support. People from those different languages from different companies are contributing to it. But there is still a lot of work. This is a representation of work going on specifically in C++. I don't have time to go into details, but there is work going on other file formats, on a dataset interface to have, based on the different file formats, have a more broad support for partitioned datasets and things like that. Also further developing the different parts of the project. So a lot of work is still going on, is needed to further expand the ecosystem. So if you're interested in this, you're very welcome to get involved. We're trying to build a community in Apache Arrow that is around these open standards, that's, so we can share implementations there. So here there's the development mailing list, GitHub repo where you can find all information to get involved. And specifically, I mentioned in the beginning that I'm working for Ursa Labs. So for companies who would be interested in this and want to support this financially, this is an organization set up by Wes McKinney and Hadley Wikin from our studio, and it's a non-for-profit meant to raise money from companies to then support developers to work on Arrow and to further work on this ecosystem. So thanks for listening, and I also want to thank Wes McKinney, because my slides were largely based on slides that he made before. So if you have any questions, feel free to ask.
So I guess we have something like 3 minutes for questions. Let's see.
Yeah, so the question is about that if packages start to use this, that the underlying implementation might be shared, but the front end is different. So it's certainly the idea that based on the same tools under the hood, it enables people to build different front ends. For example, there are quite some people currently not very happy with the Pandas API. There are regularly people complaining about it, but currently it's very difficult to reuse like the internals of Pandas to build a different API. The idea of Arrow is that you can, with basically the same implementations under the hood, give a different front-end user API. Yeah, so the question was, in C++ on our memory, can you slice it, can you calculate reductions? First, that depends on the implementation. So I don't think that all implementations like in Go or JavaScript implement all those things. But the C++ one, and also all the languages that are based on that one, it's ongoing work to have computational tools. So things like slicing is already implemented. Filtering, Boolean filtering is something that's implemented, and some reductions or things like that are also implemented. Hash-based things like unique is also implemented, but that's ongoing work to provide those computational tools based on the memory, and then it can be used by all the libraries using the C++ library.